It says that the proportion of success in the population is 0.4. That's telling us that pi equals 0.4 is right in the center of our null distribution. It also tells us that our distribution of sample statistics has a standard deviation of 0.03. That's telling me that the distance between these vertical lines is 0.03. So I can go ahead and add 0.03 to the 0.4, which was in the center, to get 0.43 as the value that would occur at this first vertical line to the right. I can add another 0.03 and it would land me at the second vertical line. So if I start at 0.43 and add another 0.03, I'd be at 0.46. Similarly, if I go backwards, starting at the middle at 0.4, I go backwards 0.03 units, I'll land at 0.37 as the first vertical line to the left, and then another 0.03, and I would land at 0.34. Next, it asks us to think about all of this in terms of standardized statistics. Since we're talking about pi and p-hat, we're talking about z-scores. The standardized statistic would be called a z-score. So right in the center, the value 0.4 would have a standardized statistic of 0. If you had a sample statistic equal to 0.37, that would have a z-score of -1. If you had a sample statistic equal to 0.34, that would have a z-score of -2. Going up the other way, a sample statistic of 0.43 would have a z-score of 1, and a sample statistic of 0.46 would have a z-score of 2. Our sample statistic, they told us, we had an observed statistic of 35.2%. So our actual observed statistic with p-hat equals 0.352, and we can put that on our null distribution here and get a sense of what our standardized statistic would be. 0.352 would be here in between 0.34 and 0.37. So our sample statistic falls between a standardized statistic of -1 and -2. It will have a z-score that's negative, and more particularly, it's going to be between -1 and -2. We can actually calculate the value of the z-score. We can calculate the value of the standardized statistic using the formula. The formula says you take your statistic and you subtract the mean of the null distribution, and then you divide by the standard deviation of the null distribution. So our z-score, our statistic is 0.352 minus 0.4 is the mean of the null distribution, divided by the standard deviation, which was 0.03. I subtract the numerators, I get -0.048, and I need to divide that by 0.03. When I divide, I get -1.6. The z-score for our observed statistic is -1.6. The standardized statistic for our statistic is -1.6. Our observed statistic is 1.6 standard deviations below the hypothesized value of the parameter. Notice, that's not unusual. It's not more than 2 standard deviations away. So we would say in this situation, the null is plausible. You can kind of see that in our drawing as well. It's not quite out in the tail. It's not out here beyond 2 standard deviations.